Okay, everyone, just talking you through the algebra. There's basically 4 sections. The first one is algebraic fractions, and you always factorise first. The next one is inequalities, then simultaneous equations, then quadratics. So that's your 4 main bits there. Within algebraic fractions, you could be asked to add, subtract, multiply, divide, or have equations. Okay? If you're asked to add, subtract, you have to have the same denominators. If you're asked to multiply, you cancel top and bottom. If you're asked to divide, the fraction after the division sign goes upside down and you multiply. And if you have equations, you add or subtract first, then you have fraction equals fraction, so you cross multiply. So that's algebraic fractions and always factorise first. The next bit is inequalities. You have quadratic inequalities, that's x squared. So you solve as a normal quadratic equation to find the critical values. That's where it crosses the axes at. You sketch your graph and then you determine the region. Next you're going to have down here simultaneous equations. Okay? You make one letter the same by multiplying. So you'll have an x, y, and z. So you'll choose one to make the same by multiplying. Then you choose 2 different pairs of equations and eliminate the chosen letter by adding if the signs are different and subtracting if the signs are the same. It's a wrong way round to normal. Then you repeat the process of choosing one letter to make the same in the new equations. Sub your value back in to get the second letter. Sub both values back in to get the third. You will see me working through those. So you have algebraic fractions, inequalities, simultaneous equations, and quadratics. Quadratics, there are 3 things you could be asked to do. Factorise, and that's just following your normal rules, common numbers, common letters, difference of 2 squares, the grouping, that's the 4 terms, easy quadratics, harder quadratics. You've then got completing the square. So you halve the middle, you put it in the bracket squared, so x plus your half squared. You subtract the half squared bit, your new number squared, drop down the end number and tidy up. Again, you'll see me working through that. If you are completing the square, they can ask you 3 things. 1, either to solve the equation, sketch the graph, or find the maximum value. So that's quadratics. And also, you've got your formula. That's your x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now what I'm going to do is I'm going to just run through. I have it split in half. So this is fractions, equations, and completing the square. So we'll see what we're like. So you see the fractions there, the first question. So fractions always factorise first, that's what I'm doing. You're adding, so make the bottoms, they cancel down to make it even easier. Nearly missed that. Make the bottoms the same. Then you add the tops, if you remember that. Part 2 is an equation. So if you look there, that's your answer to part 1. So just put your answer to part 1 in there. Then you're going to solve it. Bring that up to the other side, multiply it out. It's a quadratic, so put everything on one side. And then you're going to solve it. Okay, by completing the square. They specify that you have to use completing the square. So half the middle to give you 1, minus 1. Take the minus 1 squared is 1, so take away 1 squared. And then drop down the end. To solve completing the square, bring your 2 over, it becomes positive. Bring your square over, so it's the square root, plus or minus the square root, and then bring your 1 over and add it on. Okay, the next question is rewrite this equation as a quadratic. So multiply everything by x, so x squared plus 23 equals 10x, put everything on one side. Part B is asking you, or part 2 is asking you to complete this square. So half the middle to give you minus 5 squared. Take that new number away squared, so take away 25 and drop down the end. Tidy it up. Same as before, bring your 2 over, bring your square over as a square root, and then bring your 5 over. Question 8. Right, your fractions. So remember what we said about fractions. You factorise first. That's a difference of 2 squares. So it goes x minus 4x plus 4. Notice them 2 cancelled off to make it easier. Now I'm going to make the same bottoms because I'm adding them. So making the bottoms the same. This one needed an extra x minus 1. This one needed an extra x plus 4. Once the bottoms are the same, work out the tops. So 3x minus 3 plus 2x add 8. And tidy up the tops. Now, part 2 has got a hence. That's your answer to part 1. So just pop it in there. And you've got a fraction equals a fraction. So you can cross multiply. So 5 times 6 is 30. X add 1. And 5 times that. So if times out your 30, times out your double bracket, tidy up your double bracket, times it by 5, put everything on one side because it's a quadratic, tidy it up. If you notice, when it equals 0, I can divide everything by 5, but you can only do that if it equals 0. So dividing everything by 5, I can either factorize or use the formula. I factorize, because what multiplies to give minus 10 and adds to give minus 3? It's a minus 5 and a 2. Okay? So then you put each bit equals 0, so x minus 5 equals 0, x add 2 equals 0. Bring that across to get x equals 5, bring that across to get x equals minus 1. Okay, the next one, number 10. You have this here shape, x and x minus 9. The big square area is x squared. And what I did, I worked out one triangle. Remember how to find a triangle? It's base times height divided by 2. So it is x minus 9 times x minus 9 divided by 2. So I multiplied out the tops, tidied it up. I want 4 of these triangles. So I took this answer here and times it by 4. 4 over 2 cancels to give you a 2, then times through your bracket. You're told in the second bit of this, the 4 triangles equals 1/8 of the square. So here's my 4 triangles. And my square is x squared from up the top of the page. I multiplied everything by 8 to go to that fraction. So times each and everything by 8. Brought that x squared over because it's a quadratic and everything has to be in the same side. Now you can factorize or use the formula. I didn't fancy using the form or factorizing that. So what I did, A, B, make sure it's a minus, and C. So you write your formula out, minus, minus, b squared. This will always be a positive number because if you square a negative, you always get a positive. Take away 4 times a times c. Make sure you work this wee bit out first. Then take away. Then you can work that worked out. Then split it up. 288 adds 72 over 30 and 288 minus 72 over 30. Now, so x could be 12 or 7.2. Let's look at this. If x was 7.2, this wee length in here could not be 7.2 take away 9. It'll give you a negative number. So the only answer possibly could have is x equals 12. Now, the next wee bit of that, hence find the area of the plate. So the area of the square is 12 twelves. The area of one triangle, you know what the x is. So area of 4 triangles, times that by 4. Area of the octagon is the square. Take away your triangles. Number 16. You've got this. If you ever see y, fx, it's the same as y equals. So you complete this square. Half the middle one. Take away this squared. So 2 squares 4. Drop down the end and tidy it up. And then it's wanting you to ask the minimum value. An x squared curve is a happy one looking like that. And the wee rule is, if you're inside the brackets, you do the opposite to the x's. So I'm going to move this forward 2. Okay, so that is x minus 2 squared. I now have to drop the graph down 9. So you're dropping this down 9. So the lowest value, the minimum value this is, it goes down to minus 9. And that happens when x is 2. Question 9 is fractions in both bits. So fractions factorise first. So what multiplies to give 8 and adds to give 6 is 4 and 2. Make the bottoms the same. So this here fraction needs an extra x plus 4. Once the bottoms are the same, just add the tops. Now, with fractions, you always want to factorise. I can pull out a 2. And then that cancels down. Those two factors cancel. The next one, factorise first. Difference of two squares, common number. Divide it by what multiplies to give minus 12 and adds to give 1. So it's a 4 and a minus 3. So now you're going to turn the second fraction upside down and multiply, and then just cancel off tops and bottoms. And question 14 is tricky. Really, really tricky. So Mark drove to his cousin's wedding in Roscommon. It had 2 stages. So you can see me writing out stage 1 and stage 2. For the first stage, the distance was 140 and the speed was x. So I automatically worked out the time. So time is distance over speed. Then the second stage, he travelled, the distance was x, his speed was 64. I'm going to work out the time. So time is distance over speed. So write down the expressions for the time. So that's it done. Part 2, the total time was 3 hours. So this time, add this time, was 3. I made the bottoms the same, make them both 64x. Times this one by 64, times this one by x. Bottoms the same, add the tops. Then I brought this bottom over so it became multiplying. It's quadratic, put everything on one side. Factorise or use the formula, and that's just me running through the formula there. He did not break the speed limit, and you were told that the speed limit was 96, so you couldn't have chosen this here as an answer. X is 80. And then find out his total distance, stage 1 plus stage 2 distance. 2015. Completing the square. Half the middle, take it away squared, it's always a take away, and tidy up. Bring your 23 over, bring your square over as square root, and bring your 5 over as an adding. Now, check and see how much more we've got to go here. Oh, we're nearly there. Number 3. So a wooden box is x by a half x by a third x. And you're told the surface area is 72. Now to find the surface area, it's the base, which is x times a half x. The top's the same as the base. The front, that's the front there, is a third times x, times another x. The back is the same. The left-hand side and the right-hand sides are both a half x times a third x, are the same, equals 72. So this is me tidying this up. X squared over 2, x squared over 2, etc., etc. And then I'm tidying up. Half x squared plus half x squared is 1x squared, 2/3 x squared, and that's 2/6 or a third x squared. 2/3 plus 1/3 is another x squared, so I'm left with 2x squared. So x squared is 36, x is 6. Number 8, fractions. Factorise first. So put brackets around that, pull out your 2x, leaving you 3x minus 1. Turn this one upside down and then cancel. The 2 and the 4 cancels and the x cancels, leaving you that on top, and just watch it be 2 on bottom. Part 2 of this one is, or part B, fraction. Factorise first. Pull out your x, pull out and factorise the bottom. Knock off top and bottom, and you're left with that. Part 2, hence. So you're going to use your answer for first part for this. So you've already this worked out, just replace it. This needs factorised, difference of 2 squares. Make the bottoms the same. This one needs an extra x minus 1, so pop it on top. Bottoms are the same, so you add the tops, times that out, x squared minus x. So tidy up, factorise, cancel, and you're left with that. And last question. Okay, nothing factorises there, so just make the denominators the same. This one needs an extra 2x, add 1, so pop it on top. This one needs an extra x plus 3, pop it on top. Once the bottoms are the same, times out the tops and tidy it up. Part 2 is hence. That's your part 1 answer, so pop it in there and equals minus 2. Bring this up to the far side, times everything by minus 2, put it all on one side, tidy up, you've got a nice quadratic. You can either factorise or use the formula. I factorised here, but the formula will work out just as well. So it's one of these AC ones, if you remember that. A times C is 56. It's made up of a 7 and an 8, which gets you 15. So remember 15x is rewritten as 7x add 8x. Take the first 2, pull out your x. Take the next 2, pull out your 2. And if you've done this right, you'll have the matching bracket. Pull that out, leaves you x plus 2, put each bracket equal to 0 and solve.